the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Hello and welcome. Today on Kaduna State Ministry of Education e-learning platform, the subject of discussion is chemistry. And we'll be continuing from where we stopped in our last lesson. Like I did promise that this topic will be continued in today's lesson. Remember, the topic is mass-volume relationship for chemical reaction. And like I said, we'll be looking at stoichiometry. And under stoichiometry, we'll be looking at stoichiometry of reaction, IUPAC convention, and SI units, relationship between quantities, concentration of terms, calculation and application of relationship. Like I said in our last lesson, the more exercises you attempt, the better your understanding of this topic. Now let's look at the SI units and the convention once again. Mass, I said, is small letter m, is measured in grams or kilograms. Molar mass or atomic mass is capital letter M, with measured in grams per mole. Molar volume is V, measured in centimeter cube or decimeter cube. Molar concentration is capital letter C and is measured in mole per dm cube. Mass concentration P is measured in grams per dm cube. And of course, Avogadro's constant or Avogadro's number in per mole. Remember, it has a value of 6.02 times 10 raised to the power of 23. My wonderful students, we're looking at again our formulas that we'll be applying in today's calculation. We say amount in moles is mass in grams over molar mass. Now, if you look at your number of moles, small letter m, is mass, small letter m, all over molar mass, capital letter M. Now we say number of particles. Remember in my last class I said number of particles can be number of molecules, number of atoms, number of ions, number of electrons, and so on and so forth. So number of particles is equal to amount in moles times Avogadro's constant, where your number of particles is capital letter N and is equal to amount, which is small letter n, times L, which is Avogadro's constant. Avogadro's constant is obtained by number of particles over amount. It's just an interchange and making subject formula from the formula that we have mentioned previously. Then of course we have molar volume, which is volume over amount. We'll be looking at the concentration terms like I mentioned in my previous lesson. Just a recap. We say molar concentration is amount in moles over volume in centimeter cube times 1000. Remember, I did say that the 1000 is a factor that converts centimeter cube to decimeter cube, such that concentration, which is capital letter C, is equals to amount in moles, small letter n, over volume in dm cube. The other one is mass concentration, which is equal to mass in grams over volume in centimeter cube times 1000. Of course, I said there's a relationship between mass concentration, molar concentration, and molar mass, such that you have mass concentration in grams per dm cube is equal to molar concentration in mole per dm cube times molar mass in grams per mole. Now, the last formula I will be mentioning today is your CaVa over CbVb is equal to Na over Nb. Now, if I am to interpret the terms in CaVa, I will say Ca is equals to concentration of A in moles per dm cube. Cb is concentration of B in mole per dm cube. Va is volume of A in centimeter cube. Vb is volume of B in centimeter cube, while Na is number of mole of A or mole ratio of A, and Nb is number of mole of B or mole ratio of B. Remember, both Na and Nb are gotten from the equation. Usually when you balance the equation, the coefficient of acid is your Na and the coefficient of base is your Nb. Now we start with this example, and the example reads, when powdered magnesium is heated to redness in a stream of nitrogen, magnesium nitrite, which is Mg3N2, is formed. 1. Write an equation for the reaction. 2. Hence, calculate the amount in moles of magnesium nitrite, Mg3N2, that can be obtained from 3.0 grams of magnesium. Remember, magnesium is equal to 24 and nitrogen is equal to 14. This question was taken from West African Examination Council, 1998. Now look at the solution. The solution says amount in mole is equal to mass in grams over molar mass, such that from our question, the mass of magnesium is 3 grams and the molar mass of magnesium is 24. So if you divide 3 by 24, you will get 0.125 moles. Now, if you look at the equation of the reaction, you find out that 3 moles of magnesium will produce 1 mole of magnesium nitrite. So that 0.125 mole of magnesium will produce unknown mole of magnesium nitrite. So if you do the proportionality, and give me the slide before this, if you look at the equation in the slide before, okay, you find out that magnesium is equal to 24 and nitrogen is equal to 14. So if you look at the application, you find that 0.125 mole of magnesium will produce X mole of magnesium nitrite. The proportion is such that 3 moles times X mole is equal to 0.125 mole times 1 mole. That's when you cross multiply from the proportionality that we have on the board. You find out that X mole, which has been made subject of the formula, will be equal to 0.125 mole times 1 mole all over 3, which will give us 0.042 moles. Now, if you look at it, you find out that, or you can say 1 over 3 times 0.125 moles, you will get 0.042 moles of magnesium nitrate. This is one way to solve this problem. But alternatively, if you want to solve it the other way around, looking at the equation, you find out that 3 moles of magnesium will combine with 1 mole of nitrogen to give you magnesium nitrite. So you find out that 1 mole of magnesium is equal to 24 grams. X mole of magnesium will be equal to 3 grams. So you make X mole is times 24 grams, which is 1 mole times 3 grams. When you cross multiply, that means 1 mole of magnesium will be multiplying by 3, and X mole of magnesium will be multiplying by 4. Making X mole subject of the formula is equal to 1 mole times 3 grams over 24. And you obviously will arrive at the same answer as we arrived earlier, which is 0.125 mole. Now, having gotten this 0.35 moles, you can substitute in your formula that we have done earlier, and you arrive at the final answer. Now, let's look at another example. It says zinc solid plus tetraoxosulfate 6 acid aqueous reacting to give you zinc sulfate plus hydrogen gas. It says in the above reaction, how much zinc will be left unreacted if 3 grams of zinc is reacted with 20 centimeter cube of 0.1 mole per dm cube tetraoxosulfate 6 acid. I'll take the question again. Zinc solid plus tetraoxosulfate 6 acid to give you zinc tetraoxosulfate 6 plus hydrogen gas. It says in the above reaction, how much zinc will be left unreacted if 3 grams of zinc is reacted with 20 centimeter cube of 0.1 mole of dm cube tetraoxosulfate 6 acid. Now, if you look at zinc is equal to 65, that's the atomic mass. Sulfur is 32, oxygen is 16, and hydrogen is 1. So looking at it from the solution, you say using the expression concentration, which is capital letter C, is equal to number of mole or amount in mole, which is small letter n, over volume. You find out that where C is concentration in mole per dm cube, small letter n is amount in moles, and V is volume in dm cube. So that to convert volume from centimeter cube, which is 20 centimeter cube, to decimeter cube, you divide by 1000. 1000 is the factor of conversion, and you have it to be 20 divided by 1000 to give you 0.02 dm cube. So that if you substitute making n, small letter n, which is number of mole, as the subject of the formula, you have n is equals to concentration times volume. And from our question, our concentration is 0.10 mole per dm cube, multiplied by our volume in dm cube, which is 0.02 dm cube, and you will get your final answer to be 0.002 moles. 0.002 moles. Now, this is the number of mole, or the amount in mole. We are asked to find the mass. So we go to relate that 1 mole of tetrasulfate 6 will react to 1 mole of zinc. So 0.002 moles of tetrasulfate 6 acid will react with 0.002 moles of zinc. So we are using zinc because we are asked to calculate the mass of zinc. And obviously, you remember your amount in mole is mass over molar mass. Now, if our amount in mole is 0.002 moles and our molar mass of zinc is 65, and you make mass subject of the formula, you have mass is equals to amount times molar mass. So if you substitute our amount as 0.002 moles times 65, you will get 0.130 grams of zinc. It means that 0.130 grams of zinc reacted until completion. Remember, it reacted with excess tetrasulfate 6 acid. So the question is, how much of the zinc was left unreacted? Meaning that 3 grams of zinc was given for this reaction. So if we use only 0.130 grams, for us to get the mass of zinc unreacted, we'll use this relationship. We say 0.130 grams is the mass of zinc that reacted. So mass of zinc left unreacted will become 3, which is the mass of zinc initially given at the question, minus 0.130 grams of zinc that reacted. So the mass of zinc left unreacted is 2.87 grams. 2.87 grams. Happy that you've been following what I've been doing so far. I will take the next example, and the next example reads 20 centimeter cube of 0.1 mole per dm cube potassium hydroxide neutralized 25 centimeter cube of tetraoxosulfate 6 acid solution. What is the molar concentration of the acid? Remember, the acid in question here is tetraoxosulfate 6 acid. So looking at the equation, that we'll be presenting, you find out that from the equation, H2XO4, which is the acid, plus 2KOH, which is the base, will react to give you a salt, K2SO4 plus water, knowing that neutralization reaction is a reaction between an acid and base to give you salt and water only. So this is a neutralization reaction. Now, the equation has been balanced. The mole ratio is 1:2, as against acid having a ratio of 1 and the base having a ratio of 2. And from this, we can apply our formula, which says that CA VA over CB VB is equals to NA over NB, such that if you make proportionality, where CA is concentration of acid, which is unknown, CB is concentration of base, which is given in the question as 0.10 mole per dm cube. VA is the volume of the acid at 25 centimeter cube. VB is the volume of base at 20 centimeter cube. NA is the mole ratio, the coefficient before the acid, which is 1. And NB is the mole ratio and the coefficient before the base, which is 2. CA is equal to CB VB NA over VA NB. What is left for you to do is to substitute appropriately. You pick CB to be 0.10 mole per dm cube from your parameters. You pick your VB to be 20 centimeter cube from your parameters, and you multiply by the mole ratio of acid Na, which is 1, all over VA, which is 25 centimeter cube, multiplied by 2. If you can see, the centimeter cube will cancel out, and your final answer will remain in mole per dm cube. If you have a calculator, you multiply 0.10 times 20, you will get 2.00 mole per dm cube. And if you multiply 25 by 2, you will get 50, as you can see there. Such that when you punch your calculator, 2 0.00 divided by 50 will give you 0.04 mole per dm cube. So that's the concentration of the acid as represented by Ca. My wonderful students, that's the solution to that question. Now we'll take another question, and this question has two salts, and I'm going to pick only one of the salt and solve. I'm sure that you will see the other salt in your assignment, which you will practice, and you use the same methodology that I have applied, and I'm sure you arrive at the answer. The question says, both calcium trioxocarbonate 4 and potassium hydrogen trioxocarbonate 4 decompose when heated to give carbon 4 oxide. It's a reaction in chemistry. When you heat a trioxocarbonate 4, you will get an oxide and carbon 4 oxide of the metal of the trioxocarbonate 4. For instance, calcium trioxocarbonate 4, when you heat it, you will get calcium oxide plus carbon 4 oxide because calcium trioxocarbonate 4 decomposes on heating. In the same vein, when you heat a hydrogen trioxocarbonate 4 of a metal, you will get a calcium trioxocarbonate 4 of that metal plus carbon 4 oxide plus water. And that's what happens when you heat temporary hardness. We say we have two types of hardness, temporary and permanent hardness. When you boil your water that is temporary hard, you will get decomposition to give you a trioxocarbonate 4, which is usually the deposit you see at the end of your pot or whatever you use for boiling. If it has temporary hardness, you see a residual brown substance after boiling water. That means that water is temporary hard. So you can see from the equation, we'll be using potassium hydrogen trioxocarbonate 4. Remember, there are two substances, so the calcium trioxocarbonate 4 will be left for you to try out later. Now, from the equation, you can see potassium hydrogen trioxocarbonate 4, which is KHCO3. The presence of hydrogen there tells that it's an acid salt, so that it will give you potassium trioxocarbonate 4 plus carbon 4 oxide plus water. So the volume of carbon 4 oxide measured at STP that will be obtained by heating 20 grams of potassium hydrogen trioxocarbonate 4. Now look at it. Amount of potassium hydrogen trioxocarbonate 4 is equals to mass of potassium hydrogen trioxocarbonate 4 divided by the molar mass of potassium hydrogen trioxocarbonate 4. And from the question, we are given that the mass of potassium hydrogen trioxocarbonate 4 is 20 grams. And the molar mass of potassium hydrogen trioxocarbonate 4 is 39 for potassium, 1 for hydrogen, 12 for carbon, and 16 times 3 because there are 3 oxygen. The atomic mass of oxygen is 16. If you sum up all this, you will get 100 as the molar mass of potassium hydrogen trioxocarbonate 4. So amount in mole is the mass, which is 20 grams, over 100, which is the molar mass, 100 grams per mole. So 20 divided by 100 grams per mole, you will get 0.2 mole. Now you get 0.2 mole as the number of mole of potassium hydrogen trioxocarbonate 4. Now from the equation, 2 moles of potassium hydrogen trioxocarbonate 4 produce 1 mole of carbon 4 oxide. Let's go back to the equation, please. From the equation, you can see 2 moles of potassium hydrogen trioxocarbonate 4 produce 1 mole of carbon 4 oxide. So, if we have seen that, we will say that 2 mole of potassium hydrogen trioxocarbonate 4 will produce 1 mole of carbon 4 oxide. So, how many mole? That's 0.2 mole of potassium hydrogen trioxocarbonate 4 will produce S moles of carbon 4 oxide, where X there is unknown. Now you are doing mathematics, not chemistry. So that you cross multiply 2 moles of potassium hydrogen triazocarbonate 4 times X mole of carbon 4 oxide is equal to 0.2 moles of potassium hydrogen triazocarbonate 4 times 1 mole of carbon 4 oxide. If you make X the subject of the formula, you have X mole of carbon 4 oxide is equal to 0.2, substituting now, times 1 all over 2 moles of potassium hydrogen triazocarbonate 4. On this equation, you will find out that 0.2 moles of potassium hydrogen triazocarbonate 4, which is on the numerator, has the same as 2 moles of potassium hydrogen triazocarbonate at the denominator. They cancel out. So what you have left is mole of carbon 4 oxide, which will be your obvious final answer and unit. So 0.2 times 1 all over 2 will give you 0.1 mole. And 0.1 mole of what? Of carbon, 0.5 moles of carbon 4 oxide. Now, 1 mole of carbon 4 oxide will occupy a volume of 22.4 dm cube, which is the molar volume of gases. Remember, I told you earlier that at STP, 1 mole of any gas will occupy a volume of 22.4 dm cube. So if 1 mole of carbon 4 oxide occupy a volume of 22.4 dm cube, 0.1 mole of carbon 4 oxide will occupy X dm cube. So if you make X subject of formula, your final answer becomes 22.4 dm cube times 0.1 mole divided by 1 mole. So mole cancel out and your final answer will be 2.24 dm cube. Now, amount in mole is equal to number of particles over Avogadro's constants. Now we are going to be calculating number of molecules. So if we substitute 0.1 mole from our previous calculation all over 6.02 times 10 raised to the power 23, you make number of molecules subject of the formula and you have your final answer as 0.1 mole times 6.02 times 10 raised to the power 23 to be equal to 6.02 times 10 raised to the power 22 molecules. That's my final example. I'm sure that you lay your hands on many more examples. In the just concluded WAEC examination, several questions like this came up. I'm sure if you can lay your hands on past questions, you will see them. And when you use any of the method I've applied, I'm sure you'll be able to get the correct answer. I've come to the end of this lesson as usual. You can contact me or any of my colleagues via these numbers that are displayed on the board. My number, Mr. Philip Mamman, is 08026598861. Philip Mamman again, 08026598861. Ibrahim Umar at 07036202842. Ibrahim Umar again, 07036202842. And Mr. Williams Ishaku, 08160670920. Williams Ishaku again, 08160670920. I remain yours always, your chemistry teacher, Mr. Philip Mamman. I'll meet you again in my next class. I'm sure you'll be prepared for another exposition. Have a wonderful day.